Okay, in this video I just want to talk a little bit about function notation and try and connect concepts from things you've seen before in other classes to what we're doing now. With functions, what you see in functions 1 or in section 4.1 in the Zybook. Okay, so in Calc 1, right, let's see, you have something like this. Okay, I want to be a good teacher, so we'll label the axes. Supposedly that means you're good or something. Okay, so there's f of x equals x squared. And to calculus students, to most people, this is what a function is, right? You say, okay, well, what is f of x equals x squared? Oh, it's this thing. Well, okay, it's not entirely true, not entirely correct. All right, so the x-axis is the real line, the y-axis is the real line. And so because we often have functions that, okay, right, and so this is a the real line is dimension 1, so it's one dimensional. And same thing, the y-axis is one dimensional. Oops. One D and one D. One dimensional, we'll call that just D, right? One dimensional, one dimensional. So you can draw a graph on a piece of paper of a one-dimensional object being mapped or by a function into another one-dimensional object. And so that's because you think about it, right? A piece of paper is two-dimensional, right? So like this piece of paper that I'm writing on here, I know it's not really a piece of paper, but think about a piece of paper or a chalkboard or a whiteboard, computer screen, all one-dimensional objects. So you can represent a function from, you got one dimension into another one-dimensional object. So you can, the abstract way of looking at this, f from 1D to 1D, well, there's no reason to look at it in the abstract. We can just graph it like we have in Calc 1 and Calc 2 and all that sort of stuff. But the issue becomes when we start having to look at functions that are not from one-dimensional objects into one-dimensional objects. Now, in Calc 3, maybe some of you will take Calc 3. Maybe if you're interested in computer graphics or video games, first-person shooters, those kinds of things. You have three-dimensional graphics. You can graph things in 3 dimensions even. You might see this in Calc 3 or something. Well, you definitely would see this in Calc 3. X, Y, and Z. So this is like a 3-dimensional axes there. And so here the function is going from it. So here the functions, let me see if I can draw one. So if you think of it like you have a 3-dimensional object. This 3-dimensional object, this red bowl here, this would be z equals x squared plus y squared. But still, here we go. This is going from the 2-dimensional plane into the one-dimensional. So it's from a 2-dimensional world into a 1-dimensional world. We can still visualize that in 3 dimensions. But things start to break down when we have more than 3 dimensions that we want to see. Some people argue you can still think in 4 dimensions if you look at it correctly, and I think that's definitely true. But it's not that easy. I've tried, believe me. And then once we get to like lots and lots and lots of dimensions, which in like data science and stuff like that, you'll be working with, if you're working with like a data set, you can think of that as a matrix. And you're looking at, and a matrix really defines a function, a special type of function called a linear transformation. I won't go into that. That's beyond the scope of the class. But in any case, the number of rows the number of rows in your data set is your dimension of the range, and the number of columns is the dimension of the domain. And so if you think about a really big data, right, we have like thousands of rows, thousands of columns. So you're looking at there's just no way to write that thing in multiple, to draw that thing in 2 dimensions, like you do stuff in Calc 1, Calc 2. So what I'm trying to motivate here in this video is just that it's really, there's no good way to represent functions using a graph like you've done in Calc 1, Calc 2, and other classes, prerequisite classes like that. And so it really becomes a necessity to be able to represent things in this abstract way with these bubble diagrams, like you see in the reading, where you have your domain and your target. Or you could represent this in a table, and that's how we'll do it in this class, is with a table. All right, so unfortunately, as much as I know you want us to do things in this way, it just doesn't make sense for later classes, and that's what this class is kind of trying to get your mind wrapped around, the abstract way of looking at things. And that's really the only way we can proceed with modern mathematics and modern computer science. All right, I think that's enough for this one, and I'll do another one with the notation and all that stuff. Okay.